that was the mathematical problems on integers serving as an excuse to use a while loop to solve that particular problem. Next, I during my teaching career, so during the old version and the new version of this course, so I have a lot of exercises from the domain of playing cards, so a familiar domain to people, and so even if you don't know the rules of the game, so I would assume that the contents of a deck of a playing card pretty much considered general knowledge among educated adults. Like, wasn't it Mark Twain that said that very strange that somebody just doesn't know the difference between a flush and a straight. But so even without that, so now we get to use a dictionary so to convert so we build up a list of the possible suits in the deck. So here given in the bridge suit ordering, and then we build up a translation dictionary that when an individual card is a tuple consisting of the rank and the suit, so the dictionary tells us what is the value. So now notice how in a dictionary we can use, so that we can have two different ways to say 2 and 3, and then converting, so we treat the aces as 14s, so then we can some of the card games that treat ace as a 1, so then we just have to do the logic in a so the change in a programmatic fashion. And the list comprehension, and the list comprehension here is a new one, so illustrating just like you can write loops inside loops, wheels inside wheels, so the list comprehension, so you can nest so all the possible values of this one, and then for each one all the possible values of that one. So we build up a list whose each element, every card is represented. We make a choice here. Many other representations would be possible in various levels of abstractions, but for now we pick up this one representation that the playing card is a tuple of 2 strings with the rank and the suit in that order, and then all the code that we write is written based on that assumption. So this for 4 suits and 13 ranks should give us 52 combos, rank and the suit. Now with the ITER tools module that we're gonna be looking at next week, so this kind of combinatorial stuff becomes a lot prettier, but the nested list comprehension, so theoretically there is no upper limit how many levels of nesting you could have here, but if there is more than 3 or 4, so something very strange is going on. The second thing illustrated in this example, so now we're gonna, of course, for the playing card games to be interesting, so we need some random hands. So we need the random number generation, which actually isn't random but completely deterministic and just very chaotic, so as good as random as far as we care. But again, we don't need to reinvent the wheel, so the mathematics, even the greatest have stumbled, like John von Neumann and similar, so they were just like we don't perform our own heart surgery, we don't perform our own random number generation, so we just import the correct libraries to do so, and then if we needed industrial strength randomness, so I'm sure they have custom modules for that also. So let's take a look at the loop, so let's do something a bit in a redundant fashion just so that we get to demonstrate what is going on. So we ask for a random card of random hand of n cards, so a 5-card poker hand or a 13-card bridge hand or whatever you're dealing. So the result, the list, we're just gonna be choosing cards one at a time, so initially no cards been chosen, eventually some cards are chosen and we return them, and so the goal is to fill in the hand with n cards, so as long as you are not on the goal, so the length of the result list is insufficient. So the various functions in the random module can be used, so because this kind of thing is so common, given a sequence, choose a random element, so chooses one element randomly and returns it, and then if the card, so that of course the replacement effect, we're not modifying the deck, we just remember which cards have been taken, that if the card is such that is not in the result and not in the taken, append it to the result. So each round either we get a successful draw or an unsuccessful draw, and then the length eventually, luckily, hopefully increases. Theoretically, there's no upper limit how long this could go, but the probability vanishes so quickly that again, it doesn't matter. Now, this whole problem, of course, so in the random module, so the random subset, so random sample of size n from the given sequence. Let's look at the one problem. So I used to have this one as a Java lab, one at the time, like in a world that was very different. So here now, resurrected as an example, it's a counting problem where we get to just iterate through the sequence. So suppose you have a playing gene, you're trying to get rid of your cards, and then even so the cards that you cannot get rid of is the deadwood that you get the negative penalty points for. So now assuming that you get rid of the cards, so then that's a whole what's the best way to get rid of the cards. So that's a very completely different combinatorial optimization problem needing the techniques from the future courses. But suppose some friendly soul has done it already, so this is your leftover card, so just calculate the penalty. So when adding up things, initialize a counter to 0, count, tally, totals, whatever you call it, so count. And whenever you find something that you're supposed to be tallying, then add it to the count. So here we just take the raw point values of the cards, but so in gene, so ace is low, so if the value is 14 that we used as the aces encoding, so value is 1, and otherwise so any card greater than 10, so this blackjack style, so is equal to 10. And notice this is one of those rare cases where we don't have an unconditional else, so otherwise else do nothing. So when it's a else do nothing, you just leave out the else altogether. A lot of students they feel like they always have to say the else in an if, but if you just wanna say else do nothing, so you just leave out the else. Then you would put like a pass statement in there. I don't even teach it because we don't need it, but so students always put some kind of a do nothing assignment from variable to itself, so because otherwise the syntax in Python doesn't allow an empty body. But so the correct thing is to do not to have an else block, so that's enough of that. So then whatever the count adds up to, so looping through, so since the cards are known to be tuples, so dictionary tells us the value and we return the count.